So we have completed measuring instruments, and I have given you the first tute, right? And I have arranged another tute for measuring instruments, including a lot of theory notes. So just read it, then that will be more than enough for the measuring instruments. So that's the end of measuring instruments. Today we are going to start the center of gravity section. Take measuring instruments note. No need to use any other. No need any other book. Use the measuring instruments note and write the heading as center of gravity. Right, what is center of gravity here? Under center of gravity, please write your first subheading. Please write your first your heading is your heading should be center of gravity. Right, so that is the this is the heading. Please use measuring instruments note. Units, dimensions, measuring instruments note. Please use that note and write the heading as center of gravity. Under that, please write the first subheading, weight of an object. Weight of an object. Okay, dear. So what is the heading? Center of gravity. What is the subheading? Weight of an object. Under that, please write the earth applies a vertically downward force. The earth applies a vertically downward force on each object. The earth applies a vertically downward force on each object, comma, when objects are closer to the earth. When objects are closer to the earth, the earth applies a vertically downward force on each object, comma, when objects are closer to the earth. Full stop. That force is known as gravitation attraction force. That force is known as gravitation attraction force. That force is known as gravitation attraction force. Gravitation attraction force. Full stop. Use the units, dimensions, measuring instruments note for this. You should write this note in measuring instruments note. Units, dimensions, measuring instruments note. Continue the note. Sometimes that force is known as the weight of the object. Sometimes that force is known as the weight of the object. Sometimes that force is known as the weight of the object. Right. Continue the description further. Okay, before that, somebody please read that note again. Somebody unmute the mic and read everything that we have written today. Somebody unmute the mic and read everything that we have written today.
The Earth applies a vertically downward force on each object, when objects are closer to the Earth. That force is known as gravitation attraction force. Sometimes that force is known as the weight of the object.
Right. Thank you very much, dear. Thank you. Right. Then please write the next subheading. Center of gravity of an object. Center of gravity of an object. So what's the next subheading here? The center of gravity of an object. This right. There is a certain point on each object. There is a certain point. There is a certain point. Actually, the term should be at. There is a certain point at each object. There is a certain point at each object through which the gravitation attraction force travels through. There is a certain point at each object, through which the center of gravity, through which the gravitation attraction force, within brackets weight, goes through. There is a certain point at each object, the gravitation attraction force, within brackets the weight, goes through, full stop. That point is known as center of gravity of the object. That point is known as center of gravity of the object. That point is known as center of gravity of the object. Center of gravity of the object. Okay, dear? Right. Somebody unmute the mic and read that note. Somebody please unmute the mic and read that note.
There is a certain point at each object through which the gravitation attraction force travels through. That point is known as the center of gravity of the object.
Okay, thank you very much. Thank you very much. Right. Then Right. Listen there. So if I consider an object like this, let's say there is a metal plate, right? If we keep the metal plate like this, the earth gives a force on it. That force is known as gravitation attraction force. Okay, dear? So let's say we, by using a string or something, let's say we keep the object like this. For example, let's say we, let's say rotate, like we rotate the object, right? So I think it's difficult to rotate the object here. Yeah. Let me use my normal whiteboard and show you the situation. Right. I think you are able to see. Look at board here. Look at board. So let's say there is a box. There is a box. Right? Then the earth gives a vertically downward force. We know how to calculate it. This is known as gravitation attraction force. The table, let's say it is connected to a string and we can keep it like this. With the help of a string, we have kept the object like this. Got it? Right. Right. Now let's say the same object is hung like this. Now this length part is here. If I name this as A, B, C, D, right? Now this is, I have rotated it. As I have rotated it, this will be AD. Once I rotate and hung it, this will be D. D, A, B, C. If I name this point as capital G, again we can identify that the gravitation attraction force starting from that point and acting vertically downward. That is the magic. Gravitation attraction force always starting from the center of gravity and going through the center of gravity. That's the magic. Right. Even if we hung this object like this, even it is hung like this. Let's say we further rotate and connect the string to the point D. We connect the string to the point D. Again, we can identify that. Again, it can be identified that. Again, it can be identified that the gravitation attraction force again acting through the center of gravity. Clear? So that's the magic. The easiest way to find the center of gravity of a rectangular object, is just join these points. Just join these points like this. Right? So they meet on the center of gravity. That is the easiest method to find center of gravity. Join them. right? If you join them, these lines will meet. These lines will meet at the center of gravity. Please draw these figures, dear. Lamai, please draw these figures. So this is the magic. Whatever the point that you use to hang this object, the object always, the gravitation attraction force always starting and going through the center of gravity. Right? So this is what I wanted to prove. Please draw this object. It's better if you listen here. It's better if you listen. Please listen. When you draw, please take AD as 2 centimeter and DB as 5 centimeter. AD 2 centimeter, DB 5 centimeter. Please measure and draw all the 4 figures. Start. And somebody please unmute the mic and read that point here. Can somebody read everything that we have written today? Somebody please unmute the mic and read everything that we have written today. Please, quick.
Heading: Center of gravity. Subheading: Weight of an object. The Earth applies a vertically downward force on each object when objects are closer to the Earth. That force is known as gravitation attraction force. Sometimes that force is known as the weight of an object. Second subheading: Center of gravity of an object. There is a certain point at each object through which the gravitation attraction force travels through. That point is known as center of gravity of an object.
Thank you very much, dear. And now draw the figure. Draw all the 3 figures. Can one more student read? One more student, please read the note.
Center of gravity. Subheading: Weight of an object. The Earth applies a vertically downward on each object when objects are closer to the Earth. That force is known as gravitation attraction force. Sometimes that force is known as weight of the object. Second subheading: Center of gravity of an object. There is a certain point at each object to which the gravitation attraction force weight weight goes through. That point is known as center of gravity of the object.
Thank you very much, dear. The Earth applies a vertical downward force on each object. The Earth applies a vertical downward force on each object. That force is known as gravitation attraction force. That's how we start the things. Okay, please write the next subheading. Write the next subheading. Please write the next subheading. Determination of the center of gravity. Determination of the center of gravity of a uniform rod. Determination of the center of gravity of a uniform rod. Determination of the center of gravity of a uniform rod. Look at board. A uniform rod means a rod with a constant cross-section area. A uniform rod is the rod with the uniform cross-section area. First, the rod is hung vertically by connecting a string like this. By connecting a string like this, right? So then this is a string. So then the gravitation attraction force should be acting vertically downward. I don't know the acting point. The gravitation attraction force should be acting somewhere here. If I mark this as mg, the gravitation attraction force should be somewhere in between A and B. Should be somewhere on the AB straight line. The gravitation attraction force should be somewhere on the AB straight line. I don't know where it is. Just think. Right. So please try. First, the given rod is hung vertically. First, the given rod is hung vertically by a string as shown in the following figure. The first given rod is hung vertically as shown in the following figure. As shown in the following figure. Draw this figure here. So it's you should draw it vertical, right? My rod, this rod is inclined, but when you draw it, please draw it vertically. Start there. The rod is hung vertically by a string. The rod is hung vertically by a string. Then draw this figure.
Excuse me, sir. Sir, you're muted.
Sorry, sorry, please slide. After that, the rod is hung by a string, and the position of the string is adjusted. The position of the string is adjusted until the rod comes to rest horizontally. After that, the rod is hung by a string and the position of the string is adjusted until the rod comes to rest horizontally. Until the rod comes to rest horizontally. Right. Look at board here. So let's say this is a string. Let's say I keep a knot like this. Right. Now my question is, will the rod be in equilibrium under this situation? Somebody unmute the mic and tell me, if the string is kept like this, will the rod be in equilibrium? Will the rod be?
No, sir.
No. Why? This end will be rotated to here. Am I right? This end will be rotated here. So what should I do here? If this is point A, if this is point B, I should move the string towards the point B. Am I right? Then let's say I keep the string like this. Will it be in equilibrium? If the string is here, now string is not this end. Will the rod be in equilibrium? Lamai?
No, sir.
No.
No, sir.
Then what should I do? I should keep the string middle point. If the string is kept like this, then it will be at rest. I can't see the other end because the other end is covered by the rod. Can you understand here? This is loosely connected, right? The string and rod are loosely connected. It's not tightly fixed. Right? Draw this figure here. Draw this figure. Right. So if I mark this point as C, and if this point is D, right? The gravitation attraction force acting downward like this engine. So the center of gravity should be somewhere. On the line C and D. Similarly, center of gravity should be somewhere on the line AB. Draw it. Can somebody read that point here? Can somebody read all the points that I have said about this road case here? For the vertical rod and for the horizontal rod, please somebody unmute the mic and read that note.
Determination of the center of gravity of a uniform rod. First, the given rod is hung vertically by a string hash shown in the following figure. After that, the rod is hung on a string and the position of the string is adjusted until the rod comes to rest horizontally.
Thank you, dear. Thank you very much. If there's any other student who are not able to write it, please send a message to Zoom chat. One more student want your help. Would you please read it once again, dear? Read slowly and loudly. The same student.
Okay, sir. Determination of the center of gravity of a uniform rod. First, the given rod is hung vertically by a string hash shown in the following figure. After that, the rod is hung on a string and the position of the string is adjusted until the rod comes to rest horizontally.
Thank you, dear. Thank you very much. So, where should be the center of gravity? The center of gravity should be at the point. Look at board. Center of gravity should be on the point at the point where AB and CD straight lines meet. So this is the center of gravity. Please write a star point and write. Star point and write. The center of gravity is the point. Center of gravity is the point. Center of gravity is the point at which center of gravity is the point at which AB and CD straight lines meet. Center of gravity is the point at which AB and CD straight lines meet. AB and CD straight lines meet. Okay. So where is the center of gravity here? Center of gravity is the point at which AB and CD straight lines meet. Draw this figure. Draw this figure here, quick. Is my audio okay, dear? Is audio clear or not? Please send a message. Right, I think time is enough. Let's give a try for some of the questions given in the examination here. So if you sometimes you may have not received the tune, but I have sent you the PDF, so you can use it. If you have not received the tune, you can use the PDF. Right. Let's check the questions which are asked from this lesson there. So I'm going to discuss the questions in this tune. I'm going to discuss some of the questions given in this tune. Somebody please unmute the mic and read this description there. This is given in the first page of the tune. Somebody unmute the mic and read this note. Is video clear now, dear? Please, I have changed the data connection. Please check whether the video is clear now.
Yes, sir.
Clear, sir.
Yes, sir.
Yes, sir.
Thank you, dear. Thank you very much. Would you please read the first page of the tune, dear? So this is what you will see in the first page. Would you please read it, dear?
Center of gravity. It is the point from which the weight of a body or system may be considered to act in uniform gravity. It is the same as the center of mass. The weight of an object. The weight of an object is the force of gravity acting on the object. Magnitude of weight is defined as the mass times the acceleration of gravity. W equals mg. Since the weight is a force, its SI unit is Newton.
Thank you, dear. Thank you very much. So then let's go to the next page of the tute. Right. Can you see the first question there? So let me increase the size. Check whether you are able to see the tute now, the first question.
Yes, sir.
Right. Please read the first question, dear.
An uniform wire is bended as shown in the figure. Its center of gravity is located at answer number 1A, second one B, third one C, fourth one D, fifth one E.
Right. It is asked, thank you, Buddha. Thank you very much. It is asked us to find the center of gravity of a given object. It is said a uniform wire is bent. So it means all of them are wires as shown in the figure. Right? They have asked us to find the center of gravity. So if this was blocked, listen dear, should identify these things. If this end of the if this end is also closed, listen. If this end is also closed, right? Then where will be the center of gravity? What's the method that we use to find center of gravity? We just join this end. We just join this end and this end. Right? So the point where the two lines meet is the center of gravity. Okay? If the fourth end is also closed, but unfortunately, the fourth end is not closed. So therefore, we have to use another method. Another method. So that method is, if I name this, listen dear, if I name this rod as P, Q, R, P, Q, R, and S, right? P, Q, R, and S, then how do you find the center of gravity of the PQ rod? Where should be the center of gravity of the PQ rod, dear? Lamai?
Middle, sir.
At the center. Very good. Center of gravity of PQ rod should be at the center, somewhere here. Where should be the center of gravity of SR rod?
Center, sir.
At the center. Where is the center of gravity of QR rod?
E.
E.
Oh yes, at the center, that is letter E. So then center of gravity of the entire system, the center of gravity of the entire system can be found like this. We can join this these 2 points. I should move it. So center of this SR is here, right? Then we should join, wait, like this, right? Now center of gravity should be inside this triangle. This is another method. There are several methods to find center of gravity. If we are not able to use these methods, then we have to go for a calculation. But in the examination, we should avoid calculations. Why is that here? We should try our maximum to get the answer without doing calculations. Can somebody tell me the reason?
To save the time, sir.
To save the time. Very good. You are excellent. I'm so happy with you. I'm so happy with the answer. Yeah, because this is a huge game with the time. Therefore, we must try our maximum to save the time. Very good. So in the examination, we must try our best to save the time to obtain the answer, right? Please start. What is the? I don't remember this year. Yeah, this year. What is the year here? 1998. So please write. Write the heading past paper questions. Write the heading as past paper questions. Then write 1990 AL question. No need to write the question. It's something like this. You should write the heading as past paper questions. Then write 1990 AL. Then you draw this figure. That's what you want to do. Okay, dear. Just write the heading as 1990 AL. Then draw this figure. Start. So we are going to discuss last 30 years past paper questions given from this lesson. Start here. Draw only the figure, no need to use. And I'll be very happy if you use some different colors like this. I have used several colors to draw the figure. Please do the same. Use several colors to draw the figure. Right, so below the figure, please write these points there. Please write these things in point format. X is the middle point of PQ rod, and Y is the middle point of SR rod. Then please write with me. Then the center of gravity of PQ and SR rods. PQ and SR rods should be at the center of XY line. Okay, dear. So this is the point. So what are the points that I have written? X is the center or middle point of PQ rod. Y is the middle point of SR rod. Then the center of gravity of PQ and SR rods should be at the center of XY line. Okay. Right. Then we should write another sentence. Right. Z equals E is the middle point of QR rod. QR rod. Therefore, Z should be the center of gravity. Z should be the center of gravity of QR rod. Okay, dear? Lamai, just write these descriptions. Just write these descriptions, and if you have any further doubt, you can unmute the mic and ask. Are you okay up to this point, Lamai? E is the middle point of QR. Z is also the middle point of QR. That's what I have said. So if you are, if you want, you can mark E separate. If you want, you can mark E separately like this. You can draw an arrow, right? Then easily you take Z here. So E and Z same point. Okay, dear. Z is the middle point of QR. According to the given figure, middle point of QR is E. That's what I have said. Okay, dear. Is it clear?
Yes, sir.
Right. Right.
Yes,
Very
sir.
good. Now, you should identify this point here. You should identify this point. See. Can you see that PQ and SR rods have more mass than QR. Why? There are two rods. QR is a single rod. So QR should have PQ and SR should have more mass. Am I right? PQ and SR should have more mass, you see, because PQ and QR, you see, PQ one rod, SR one rod, so mass of two rods should be greater than the mass of a single rod. Therefore, PQ and SR rods have more mass than Q. So therefore, center of gravity of the system. Center of gravity of the system should be closer to the center of gravity. Should be closer to the center of gravity of PQ and SR rods. Right. So therefore, what should be the center of gravity here? Read all the descriptions, and somebody unmute. No need to read loudly. Read the descriptions given that I have written, and somebody unmute the mic and tell me which point the center of gravity is. C or D?
C.
Yes, very good. So center of gravity of PQ and SR rods is on XY line. So center of gravity should be closer to XY line. Therefore, center of gravity. Is C. Therefore, center of gravity is C. Right. Please read the entire description, check whether you can understand. Is video clear here? First of all, tell me whether your video is clear or not.
Yes, sir.
Yes, sir.
Right. So if this kind of an MCQ given in the examination, do you write this much of a description? That's the
No, sir.
question.
No,
No.
sir.
You just imagine the thing, description. You should think. You imagine the sentences and you should get the answer. Okay, dear? Because writing a description in the examination like this in the examination is a completely waste of time. Okay, dear? So you should not waste the time. You should get the answer by imagination. You just imagine and get the answer. Okay, dear? Right. Read the question
Yes, sir.
once again. Read in all the descriptions. Check whether you can understand everything. I'll give you 2 minutes for all the students. Read the question, read my descriptions. Check whether you can understand. Start. Okay, let's go to the next question. Right, somebody unmute the mic and read the question. Somebody please unmute the mic and read the question.
A bar AE is suspended in a horizontal position by two light cords as shown in the figure. The position of the center of gravity of the bar is 1A, 2B, 3C, 4D, and 5E.
Thank you, dear. Thank you very much. You read it nicely. So for this question, we should use a special theory to obtain the answer. When this kind of question is given, we should use a special theory. It is something like this here. So let us consider this string. This string gives a force. This string gives a force to the system. I have just produced it backward. This string gives a force. We have learned that force in mechanics lesson. So let me mark the tension force given by the string like this. Got it? Similarly, this string is also gives a tension force. The two strings give two tension forces, right? And let me produce that string also. Right? So I have produced that string. Right. Now, how many forces acting on the rod here according to this description? Lamai, somebody unmute the mic and tell me the number of forces acting on the rod.
2 forces, sir.
2 forces. There should be another force. What is that force, dear?
MG.
Mg, gravitation attraction force. What is the direction of gravitation attraction force? Lamai?
Downwards.
Very good. It should always acting vertically downward, and that force should always go through the center of gravity. Am I right here?
Yes,
If
sir.
I keep the gravitational attraction force like this, what is the center of gravity here? Let's say gravitational attraction force acting like this. Let's imagine. So then what is the center of gravity?
D, sir.
Point D. If I keep it here like this, what is the center of gravity?
C, sir.
Point D.
If I keep mg force like this, what is the center of gravity?
B, sir.
B, sir.
B,
If
sir.
I keep mg force like this, what is the center of gravity?
A, sir.
A, sir.
Now
Yes.
there is a theory. Let me give you that theory. Before I mark this mg force, there is a theory, isn't there? If an object, can you see this board if I type here?
Yes, sir.
Yes, sir.
Yeah. If you can't see the board, please tell me. If an object is at rest, if an object is at rest under the influence of three forces. If an object is at rest under the influence of three forces, the three forces should meet at a single point, or they should be parallel to each other. They should be parallel to each other. They should be, sorry, they should be parallel to each other. Right. So somebody unmute the mic and tell me whether these forces are parallel. Are these
No,
forces
sir.
parallel to each other
No,
or
sir.
not?
No, sir.
No.
No, sir.
Then can we satisfy this parallel condition?
No, sir.
No.
No. So then what is the condition that we are able to satisfy?
They should meet at one point.
Yeah, very good. The three force should meet at a single point. So let me keep mg. So mg force should also go through this point. Am I right there?
Yes, sir.
So
Yes, sir.
just move it up. Just move the mg force up like this. Right. So according to this diagram, which point is more suitable to be the center of gravity? Now I
sir.
C, sir.
Yeah. C is very much closer to the red color arrow line. Therefore, center of gravity should be the point C. Okay. Right. So please write the heading as 1991 AL. Underline, draw the figure, write the description. Draw the figure and write the description. Start here. Right. So we can if you want, we may add one more sentence, right? The nearest point to the weight. The nearest point to the weight is C. So therefore, center of gravity should be C. So even in the exam, this is a past paper question. I have not changed the diagram. So sometimes this arrowhead is not exactly going to the point C. Okay. Sometimes the MG arrowhead will not exactly going through the points given in the examination. So we have to select the nearest point. We have to select the nearest point. Okay, dear. Right. Who wants more time to draw the things? No need to draw the no need to write the question. You just want to draw the diagram and mark the three forces and write the descriptions that I have written in red color, that I have written in blue color. Who wants more time? May I go to the next question, Lamai? Okay, I'll give you 1 minute. Don't worry. Yeah, sure, I'll give you 1 minute. Take your time and send a message saying done once you complete. Once you complete the note, send a message to the Zoom chat saying done. Right, I think time is enough. If you want, please take a screenshot. If you want any more time to write the things, please take a screenshot. I'm going to go to the next question. Right, let's go to 1992 question. Let's go to 1992 question. Right, somebody unmute the mic and read 1992 question. Start here.
A thin plate of irregular shape is suspended freely by a cord from a point A as shown in the figure 1. Next, the plate is suspended freely from another point B as shown in the figure 2. The center of gravity of the plate is most likely to be found at 1P, 2Q, 3R, 4S, and 5T.
Thank you, dear. Thank you very much. Now, so simple. The method is very simple. We have learned the method. Center of gravity. The object, this is the plate, it is hung by the point A. Therefore, center of gravity should be, where should be the center of gravity? It should be somewhere on the line joining A and A1 points. A and A1 points. Am I right here? Just tell me yes or no.
Yes, sir.
Yeah. Now, the string is connected to the point B. Therefore, center of gravity should be somewhere on the line, on this line, on the line B1, if you want. Am I right here?
Yes,
According
sir.
to the first figure, center of gravity should be somewhere on A1. According to second figure, center of gravity should be somewhere on B1. B1 point is not marked, unfortunately. Okay, dear? Right. Then, where should be the center of gravity? Finally, where should be the center of gravity? it should be according to the first figure, center of gravity should be on A1 line. According to the second figure, center of gravity should be on B1 line. So center of gravity is the point where the 2 points, where the 2 straight lines meet each other. So what is that point there?
R, sir.
R,
sir.
The nearest point, we should select the nearest point. So R is the center of gravity, right? So it depends on the points that they have marked, but they have not clearly marked A and A1 points on the second figure. Unfortunately, they have not marked A and A1 points correctly on the second figure. Wait, I'll check. Unfortunately, I do not have the past paper with me now. If I mark center of gravity like this, so then what is the nearest point here? See,
S, sir.
it should be S, right?
Yes.
Yeah. Please draw this. Please write the heading as 1992 AL, the question number 16, right? Underline it and draw the 2 figures and write center of gravity should be S. Because unfortunately, here they have not marked this A and A1 points clearly on the second figure. So that's the upset. But this is the method. I think you understood the theory. The method is clear. So in the exam, if they have given such a figure, just join the 2 points A and A1, then join the points B and B1. A1, B1 line meets at a certain point, and that point is the center of gravity. Draw the 2 figures here, quick. You should draw them, right? Use the theory note, units, dimensions, measuring instruments. Draw these figures. Who wants more time to draw the figures, dear? If you have completely drawn them, send a message saying done to the Zoom chat. Send a message saying done to the Zoom chat if you have completely drawn the figures. Right, if you want, please take a screenshot. If you want any more time to draw the figures, please take a screenshot. I'm going to go to the next question. If you want, please take a screenshot. Okay, let's go to the next question. That page is over. Right. Question number 4. Question number 4. Can somebody unmute the mic and read question number 4? Somebody read it.
The diagram given is a cross-section of a toy placed on a horizontal table, which always return to the upright vertical position when the screen is unclear, not clear, sir.
Where is I'll read. Thank you, Buddha. I'll read. The diagram given is a cross section of a toy placed on horizontal table, which always return to the upright vertical position when released. So if we keep this object like this, if it is released at rest, it will be vertical. ABCD lines, the line joining ABCD will always be vertical. The object will always be vertical. That's what it is saying. The center of gravity of the toy is most likely to be. So how do we find that point there? So listen here. First of all, we should find the point of contact. What is the point of contact? Let me mark it. The object is in contact with the ground here. So this is the point of contact. Am I right? So that is the point of contact. And we should draw a line, we should draw a vertical line to the point of contact. We should draw a vertical line to the point of contact. That's the next thing. So what is the next thing here? First, we should find the point at which the object is in contact with the ground. That's the first point. Right. Now, you see that line going through the point B. If you want, we want to take this object, even you see this arrow, we want to take the object vertical. So, look at board. If I mark the weight of the object, if I mark the weight of the object through the point C, because of this force, what will happen here? The object will be rotated to this direction. Can you identify that here? We have learned something so-called moment of a force. What is the moment of a force there?
Force into perpendicular distance.
Force into
So the
perpendicular
result of
distance.
velocity.
Very good. Very good. It is the force into perpendicular distance. If the force is mg, right? This mg force, due to the mg force, the toy will be rotated into the clockwise direction if it is acting to the point C. Am I right here? Lamai?
Yes, sir.
Yeah. What is the moment of this mg force about the point of contact? Let me mark P as the point of contact. Point of contact. So what is P here? P is the point of contact, right? And I have drawn a vertical line through the point of contact like this. And I don't know whether C is the center of gravity or not. I don't know. And I have marked mg force through somewhere. So let's keep it somewhere else. Otherwise, you will think center of gravity is the point C. So let me increase the length of this arrow. Right. Now things are clear. Right. So let me mark the perpendicular distance also. Let me mark the perpendicular distance also. Right. Let me take perpendicular distance as simple d. Perpendicular distance is simple d. Then what is the moment? The moment about point P equals force is mg, perpendicular distance is simple d. Am I right here? Lamai?
Yes, sir.
Right. First
Yes,
of
sir.
all, you write the heading as this is 1994 question. Am I right here? Yeah, this is 1993 question. So please write 1993 AL question Q25. Draw this figure exactly like this and write moment about the point P equals mg times d. Okay, start there. 1993 AL Q25. Draw this figure and mark all the things and write moment about the point P equals mg times d, force into perpendicular distance. Start. Right? Did you draw it here? Who wants more time? Lamai, who wants more time? Right. So then, according to this description, what should be the most suitable point to be the center of gravity? Lamai? Okay, I'll give you further help. Star point and right. Due to the above moment, star point and right, due to the above moment, the toy is rotated due to the above moment. If you want, please take a screenshot. I'm going to list these things. If you want, please take a screenshot. Due to the above moment, the toy is rotated into the clockwise direction. Due to the above moment, the toy is rotated into the clockwise direction. And it will be vertical. Okay, dear? Due to the above moment, the toy will be rotated into the clockwise direction and it will be vertical. Okay, dear? Right. Full stop. If it is rotated to the right hand side direction, if it is rotated into the right hand side direction, comma, the same moment, if it is rotated into the right hand side direction, the same moment should be acted into the clockwise direction. The same moment should be acted into the clockwise direction and bring the object to the vertical position again. Right. Can somebody read that note once again, dear? Somebody unmute the mic and read that note once again. Just read the starting points, after that I'll help you.
Due to the above moment, the toy is rotated into the clockwise direction and it will be vertical. If it is rotated to the right hand side direction, the same moment should be acted to the clockwise direction and bring the object to the vertical position again.
Thank you, dear. Thank you very much. So let's say the object is rotated and it becomes vertical. Right? The object becomes vertical like this. Right? So let me draw the ground. This is the ground. Right? So that line gives the point of contact. Let's say this is further rotated like this. Right? So it is rotated to the right hand side like this. Right? So then the point of contact is this. Right? So object is in contact with the ground at the point E. So what should we do here? We should draw a vertical line through the point of contact. We should draw a line, vertical line through the point of contact. Let me change its color. Right. So this is a line going through the point of contact. Now what should happen here? What should happen? This object, right, like this. So this is the point of contact. Now what should happen here? Lamai, there must be a moment into the clockwise, anti-clockwise direction. Am I right?
Yes, sir.
Right. So then, according to this figure, it's very much clear that vertical line going through the point C. So if mg is acting through the point C, so let me draw the mg force here. If mg force is going through the point C, right, it cannot create a moment. Am I right here? Lamai, if mg force is going through the point C, what will happen here? Is it able to create a moment?
No, sir.
No. If mg force going through point B, then is it possible to create a moment?
Yes, sir.
Yeah. Just forget about point E here, it confuses. The point, this point E confuses us. Let me remove it. And now it's okay. Now point E is not in our case. I removed it. Okay. Right. Now what is the point of contact? Is it possible if mg force is acting through the point C, it cannot create a moment? If mg force acting through the point D, then it is able to create a moment. Is it clear or not clear? Lamai?
Clear, sir.
Clear. So therefore, the weight force should be acted through the point D, but not through the point C. Therefore, what should be the center of gravity? C or D?
D, sir.
D, right? So that's how you identify. So please write. Let us consider the following position. Let us consider the following position. Full stop. According to that position, let us consider the following position. Full stop. According to that position, center of gravity, according to that position, mg force will only be able to create a moment. Mg force will only be able to create a point, will only be able to create a moment. Mg force will only be able to create a moment, about the point of contact, into the anti-clockwise direction. According to that position, mg force will only be able to create a moment into the anti-clockwise direction, about the point of contact, if mg force is acting through the point capital D, therefore center of gravity, the center of gravity should be at the point D. Therefore, the center of gravity should be at the point D. Therefore, the center of gravity should be at the point D. Right. Somebody please unmute the mic and read the complete description that I have given for this question here. Somebody unmute the mic and read everything that I have given for this question, please, dear.
Due to the above moment, the toy is rotated into the clockwise direction and it will be vertical if it is rotated to the right hand side direction. The same moment should be acted to the clockwise direction and bring the object to the vertical position again. Let us consider the following position. According to that position, mg force will only be able to create a moment into the anti-clockwise direction. About the point of contact, if mg force is acting through the point D, therefore the center of gravity should be at the point B.
Right. Thank you, Buddha. Thank you very much. Is it clear for all? Is it clear for all?
Yes, sir.
Yes,
Would
sir.
like if I explain it again. If you would like, if you want me to explain this again, send a message to Zoom chat there. Right, I'll definitely explain, but draw this figure. I promise I'll explain. Draw this figure. This is the second figure that you draw for this question. This is the second figure that you draw for this question. Draw it. After that, I'll again explain. Draw the figure. Send a message to Zoom chat saying done. Then I'll again explain. Start there. Draw this figure. Send a message to Zoom chat saying done after you have drawn it. Then I'll again explain. Promise. Right, who wants more time to draw the figure? May I continue? If you want any more time to draw the figure, send a message to Zoom chat saying need more time. If you want any more time to draw this figure, send a message to Zoom chat saying need more time. Right, because I am going to show you something further, then only you will be able to understand this. Right, look at board here. What will happen if I rotate this like this? That's what I want to show you here. I have rotated this. Then I'll draw a line through the point of contact. I'll draw a line through the point of contact. Right. Then there will be a moment. What is the direction of the moment here? Clockwise or anti-clockwise? Moment due to this mg. Please unmute the mic and tell me the direction of the moment due to this mg. Clockwise or anti-clockwise?
Sir,
Anti-clockwise. So because of that moment, let me reduce this length of this line slightly. Because of that moment, the toy will be rotated into anti-clockwise direction and toy will be vertical. This toy will be vertical. Toy will be rotated and it will be vertical. Can you understand it? Right. So this is the vertical position. Now what is the moment here? Still weight is acting through the point D. Now what is the moment of this mg force? Somebody unmute the mic and tell me.
0.
0. Why? Why is 0? Because the distance to the mg force from the point of contact is 0. Mg force is going through the point of contact. Can you see it? Mg force is going through the point of contact. Therefore, moment is 0. Am I right there?
Yes, sir.
Mg force is going through the point of contact. So if we write the moment of the force is equal force into perpendicular direction. So force is mg, the perpendicular distance to the mg force from the point of contact is 0. Mg into 0 is 0. Now I'll rotate this force a little bit further. Look at board here. I'll rotate like this. Now again, I have to move this mg force. Now mg force is here. Then let's say distance to the mg force. Now there is a certain distance to the mg force. Can you see it here? There is a certain distance to the mg force, right? And now what is the moment of the force here? What is the moment of the force about the point of contact? Lamai? if the distance, perpendicular distance to the, if the perpendicular distance to the mg force from the point of contact is simple d, what is the moment there? Mg into d. Distance between this blue color line and red color line is the perpendicular distance. Distance between the blue color line and the red color line is the perpendicular distance. Am I right here? So then what is the rotating direction of the toy? What is the rotating direction of the toy? Somebody unmute the mic and tell me there.
Clockwise.
Clockwise direction. Then again, as because of this mg force, the toy will be rotated and it will be again vertical. Am I right? It will be again vertical. If it is further rotated, like this, then mg force, I have selected point D as the center of gravity. Like that, we can select any point as center of gravity and we should do this rotation. But in the examination, can you use the software to rotate? Now I have this application and I can rotate this object as I want. But in the examination, we do not have that facility. You have to do it in your mind immediately. Now, what is the rotating direction of the toy here? Clockwise or anti-clockwise?
Anti-clockwise.
Anti-clockwise. Then again, because of this mg force and anti-clockwise direction rotation, this mg force will rotate the toy into this direction. So toy again will be vertical because of that mg force. So if I further rotate it like this, you can watch carefully. So this is the point of contact. The vertical line which goes to the point of contact will go through the point C. So then what is the rotating direction of this toy here? Clockwise or anti-clockwise?
Clockwise, sir.
Clockwise. So you should identify that this kind of rotation can only be achieved if the center of gravity is empty. If I keep the center of gravity as C, will there be any rotation at this time here? For example, let's say you can argue that center of gravity is at the point C. So if you mark center of gravity as point C, then will there be any moment, any rotation to the anti-clockwise direction due to this mg force if you keep C as the center of gravity? Yes or no?
No, sir.
No, sir.
No.
No, sir.
If you keep the center of gravity as B, will there be any rotation now? Will there be a rotation into the anti-clockwise direction? Sorry, clockwise direction, not anti-clockwise, clockwise direction. There will be a rotation.
No, sir.
There will be a rotation. That rotation will make the toy like this. Am I right? If B is the center of gravity, it will be further rotated and it will fall down. Okay. Similarly, if the center of gravity is at A, what will happen? Will the toy be vertical or will the toy be horizontal? Somebody?
Horizontal.
Toy will be horizontal, but question tells us toy will always be vertical. So for the toy to be in a vertical position always, the center of gravity should be at the point D. Am I right here? That's what I have explained so far. Okay, if the center of gravity is at the point D, then only we can achieve such a thing. Then only if center of gravity is point D, the gravitation attraction force will always be acting through the point D, and that moment brings the object, rotates the object and make it vertical. Okay, here this can be achieved only by making the point D capital, making the point capital D as the center of gravity. Is it clear for all or not? Right. So please write a small note. if capital D point is selected, if capital B point is the center of gravity, if capital D point is the center of gravity, comma, 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 if capital D point is the center of gravity, comma, the weight force within brackets mg, if capital D is the center of gravity, comma, the weight force within brackets mg, will rotate the object, and if capital D is the center of gravity, comma, the weight force within brackets mg will rotate the object and keep the object vertical, keep the object always in vertical position. Capital the weight force within brackets mg will rotate the object and keep the object always in vertical position. Keep the object always in vertical position. Mg, the weight force within brackets mg will rotate the object and keep the object always in vertical position. Right? So that's how we identify the center of gravity. But in the examination, you do not have a facility to rotate the object, but you can rotate your paper. The printed paper can be rotated. Then you can rotate the object even in the examination. Can you understand here? Questions are printed on the paper. You can rotate the paper as you according to the way you want. Then you can recognize the point of contact and the vertical line going through the point of contact. So that's the point. You should identify the point of contact and the vertical line going through the point of contact. That's how you do this question in the examination. Okay, dear? Lamai?
Okay, sir.
Okay,
Right.
sir.
Yeah. So here also you can do the same thing. Without drawing a separate figure, you are able to do this same thing here. So point of contact is somewhere here. So just draw a line. Just draw a line to the point of contact. So even this figure is little bit not clear. You see that line going through the point C. So then weight force should definitely be acting through the point D. Point E is impossible because it is at the edge of a toy. So it is impossible to take the center of gravity to the edge. To an edge, it is not possible. It's very difficult when this kind of a figure. So even from this point, this figure at once you can identify capital D as the center of gravity if you have clearly found this point of contact. Is it clear for all here, Lamai? Lamai, is this clear for all?
Yes, sir.
Yes, sir.
Yes, sir.
Right. Can somebody read the complete note that I have given for this question? Somebody please unmute the mic and read the entire note that I have given for this question. Please read it slowly, then others will be able to complete the note. Start here, someone.
Due to the above movement, the toy is rotated into the clockwise direction and it will be vertical. If it's rotated into the right hand side direction, the same moment should be acted into the clockwise direction and bring the object to the vertical position again. Second point, let's consider the following position. According to that position, mg force will only be able to create a movement about the point of contact into the anti-clockwise direction. About the point of contact, if mg force is acting through point D, therefore, center of gravity should be at the point D. Next point, if D point is the center of gravity, the weight force mg will rotate the object and keep the object always in vertical position.
Right. Thank you very much, dear. Thank you very much. You can create such a toy at home. You can create this kind of a toy at home. I'll give you a simple description to achieve it. So first you should create this part using a cardboard. This part, the triangular part, should be created using a cardboard. Okay, and this circular part, the circular section should be made by using a metal. Got it? Circular section should be created using a metal. And one more thing should be done. Face something, a metal piece of metal or 5 rupee, 10 rupee coins, some heavy metal piece should be connected to here. Heavy metal piece. Then you can make such a toy. So make this toy at your home, record a video and send me. Can you understand? The triangular section should be made with the cardboard, triangular shape and this space. So these things should be created with cardboard, right? And the circular section should be made with the metal, right? So if you can't find a metal, for example, let's say you can't find a metal, then create everything using a cardboard. Let's say you can't find a metal, so create everything using a cardboard and paste. You can use super glue or something. If you, when you work with super glue, please be very careful. Get help from your father and make a heavy metal, something heavy at this point E. To the point E, connect something heavy. Then you can achieve this, right? Then you can rotate this object always in the vertical position. So give a try to make such a toy. Record the video. Show us that your toy is always always come to equilibrium in vertical position, and send your video to the WhatsApp group. That's your homework. Right. Let's go to the next question. Let's go to the next question. Right. Somebody your answer is marked. Who typed this question? Okay. Somebody unmute the mic and read the question there. Somebody please unmute the mic and read the question.
A person bends over and touches his toes as shown in the figure. The center of gravity of the person is most likely to be found at 1A, 2B, 3C, 4D, or 5E.
Thank you, Buddha. Thank you. I'm sorry that they have marked the answer. Right. So the point is very simple. Let us consider this boy as a box. The easiest thing is this. Let us consider the boy as a box. Right. So just to find the center of gravity, just join the corners like this and like this. So which point is more closer? The two straight lines meet here. So which is the nearest point to this point here?
B, sir.
B, sir.
B. So center of gravity should be somewhere here, but can you identify why it is not, why this point? For it, let me mark it. That is very important. Why point B is, let's A, B, C, D, E. Let's say it is F. Can somebody tell me? Can somebody tell me the reason for capital F not to be the center of gravity? Why capital F is not the center of gravity, but B is the center of gravity? Can you guess the reason? You see, the legs have heavy mass there. Legs and body have heavy mass, right? So if you consider this, right? So these sections have heavy mass. This part of the body has heavy mass. Therefore, center of gravity should be closer to that part of the body. Clear? More, where the more mass is available, center of gravity should be closer to the more mass section. So this section has more mass. Therefore, center of gravity will not be at the point F, but it will be at the point B. But this is the easiest method. Draw this figure here. Draw this figure. And if you have a highlighter, please highlight the region where we have more mass. Please do the same thing as I have done. Draw roughly, right? No need to draw a very beautiful boy. Just draw a boy slightly like this and highlight the section where more mass is located. Center of gravity should be closer to the more mass section, right? And boy is not exactly box, even though I have considered like that. Draw it here quick. May I show you the way I have drawn this figure when I was a student? Would like? Yeah, I did it like this. I have drawn the boy like this. You should not laugh at me, right? So this is how I have drawn the boy. So this is the boy that I have drawn when I was a student. Right? So after that, I just draw some lines to find the center of gravity. Like this. Right? But it is impossible for this point F. It's impossible for this point F to be the center of gravity because more mass is located here. Therefore, center of gravity should be somewhere here. Somewhere here at the point B. So point B should be the center of gravity. Got it here? So this is what I did when I was a student. That's how I draw the figures because I knew that I'm not an artist. I just want to be actually those days I didn't want to be an engineer. I just wanted to be a scientist. So I knew that I'm not a good artist. So this is how I have drawn the figure when I was a student. Right. Is the method clear here? Lama, is this method clear for you?
Clear, sir.
Yes, sir.
Yes, sir, clear.
Right. Thank you very much, dear. Okay, then is it enough for today? I'm a little bit tired. May I stop a little bit earlier?
Okay, sir.
Okay, sir.
Please give me the permission. Other students, only 2 boys give me permission. Girls, they don't like to give a rest for the teacher. Is that so?
Okay, sir.
Okay, sir.
Okay, sir.
Okay, sir.
Okay, sir.
Okay, I'm really grateful to your kind hearts. Boys, girls, and my dear students, see you next week. Bye. Good luck. And try to do the rest of the questions. I have sent you the PDF. Try to do the rest of the questions, right? Good luck then. See you. Bye.
Thank you, sir. Bye, sir.
Thank you, sir. Bye, sir.
Thank you, sir.
God
Bye,
bless you,
sir. God bless you, sir.
Thank you, sir.